Hello, welcome to Electrical Circuits part number 14, Series Inductive Circuit Analysis. Now today we'll be discussing a purely inductive circuit. It'll have no resistors, no capacitors, and we'll use our formulas as normal. We don't have to flip-flop them like we did in a purely capacitive circuit. That's only with a purely capacitive circuit. So we'll start off here. You see we have a circuit with 3 inductors in it. We go from our power source through L sub 1, through L sub 2, through L sub 3, back to our power source, and we only have one path for the current to flow. Also make note that we're on a 60 hertz frequency. L sub 1 is 600 millihenries, L sub 2 is 400 millihenries, L sub 3 is 500 millihenries, and we have 120 volts for our system. So in a series circuit, our total inductance is going to be the sum of the individual inductances. So we'll take 600 millihenries plus 400 millihenries plus 500 millihenries, and notice that we did put them back in standard decimal notation to come up with a circuit total of 1.5 henries. Next, we'll use our formulas to find our inductive reactance. And to do that, it is simply 2 times pi times the frequency times our inductance. In this case, X sub L1 will be equal to 2 times pi times the frequency times the inductance of the first inductor. So we have 2 times pi times 60 times 0.6. We do go back to the standard decimal notation for our calculations, and it comes up with a number that will round off to 226.19 ohms. X sub L2, we use the same process, just different inductance, and so it'll be 2 times pi times the frequency times the inductance of the second inductor. So 2 times pi times 60 times 0.04 to give us, rounded off, at 150.8 ohms. And X sub L3, we do the same process, and so we'll have 2 times pi times the frequency of 60 hertz times 500 millihenries, giving us 188.5 ohms for our third inductor. And for the total inductance, we use that same formula, but now we're looking at the broad picture, so we'll use our total inductance here. So it'll be 2 times pi times the frequency of 60 times 1.5 henries, and that'll give us 565.49 ohms for our total inductive reactance. Now we're going to be looking for the current. Our current total, we'll just use Ohm's law. Ohm's law states our voltage times the resistance, or in this case, the reactance, will give us our current. So looking for the total current, we look at the total voltage and the total inductive reactance. So 120 divided by that 565.49 will give us 212.2 milliamps for this circuit. Now, because this is a series circuit, and our series circuit rules state that the current remains constant through all components in the circuit, so I sub t is equal to I sub 1 is equal to I sub 2 is equal to I sub 3, that same 212.2 milliamps, so we can populate I sub 1, 2, and 3. Now we're going to be looking for our voltage drops. Our voltage drop at the first inductor is going to be equal, and we're using Ohm's law here, equal to I sub 1 times X sub L1. So the inductive reactance of the first inductor. So our 0.2122 times 226.19 that we calculated just a second ago comes out to be rounded off at 48 volt drop on that first inductor. For our second inductor, We'll use the current, and now, even though the current's constant, I always say the I sub 2 so that when we switch between series and series parallel circuits, we don't get confused. We know exactly what component we're talking about. And then we'll use our inductive reactance as the second one. So our 0.2122 times 150.8 rounded off gives us 32 volt drop. At our third the voltage drop at our third inductor is equal to I sub 3 times X sub L3. So our 0.2122 times 188.5 gives us to be 40 volts. Now, because we do not have any resistors in this, we can simply add it up. And if you'll add them up, you'll see we do reach that 120 volts. When we start mixing resistors and inductors in, all of our quick checks once again go out the door when we cannot use them. And now to find our bars. If you'll remember from the earlier lesson, bars is also considered to be wattless power. And so bars sub L1, using power, the pi of the Ohm's law and the power formula, var sub L1 is equal to I sub 1 times V sub 1, giving us 10.19 bars at the first one. Var sub L2 is equal to I sub 2 times V sub 2, which will give us 6.79 bars at that second inductor. And var sub L3 will be equal to I sub 3 times V sub 3, giving us 8.49 bars for the third resistor. And now we need to find our total bars. So bars sub LT, we'll use our total current times our total voltage, and that will give us 25.64 bars. Here's a list of all of our calculated values that we use as our baseline when we go out with our meters and measure this circuit with the live readings. We use them to compare so that we can contrast and see whether there's a problem in the circuit or not. If it's close, go look somewhere else. If it's out of the ballpark, foul ball over right field, then we need to look at that circuit a little closer because it has an issue with it. This concludes this part of our tutorial series. Thank you.